First off, science is the study of the physical world through observation and testing. Science is taking a look at the world around us, seeing what goes on, and then poking it and writing that down. Doing little experiments, but yet recording it, always sharing it. This is science. It is a way of interacting with the world around us to understand how it works by looking at it and poking it. We have to write it down. It needs to be reproducible, meaning other people should be able to do what we did. It should be rigorously checked by experts, and it has the burden of proof. Let me explain that burden of proof, because I think that gets lost a lot in our modern world. To be science, if I state that something is a certain way, it is up to me who made that statement to prove that it is so. I need to show my audience, the world, how it was, how I got that, what it was like. And then I need to provide that proof and let them see if they can find the same thing. That is the burden of proof. And in science, the burden of proof is very important. This separates science from a lot of other disciplines. There are many flavors of science: biology, chemistry, physics, ecology, meteorology, astronomy, geology, pharmacology, physiology, and many, many more. A lot of things that end in ology are sciences, but not all of them. Ology is just Latin for the study of, and many sciences do tend to take that on. Scientists really need degrees from accredited colleges, and they must have continuing education. Even as a teacher, not only do I have to have a degree, I have to be certified, and then I have to constantly go in for more education. Every year, hours and hours and hours, just so that I can keep up my professional level and let everybody know that I can be trusted. Scientists have to do the same thing. And for those of us who are teachers and scientists, yeah, we keep up on that. I'm constantly going in for more education because it is important to keep my skills sharp. Now, I found this picture last night and I really liked it. First off, it breaks down the universe in the scale of meters, talking with a particle, an atom, a cell, a human, Earth, solar system, Milky Way, and the visible universe, all kind of letting you know how that is in meters. Then it shows you how science has developed. It started with logic, then it went to mathematics, physics, chemistry, cellular biology, functional biology, which led us to psychology and sociology, as well as geoscience and astronomy. So these are how kind of science grows and affects each other. And I thought this was pretty awesome. I really like this picture. I've never seen it before, and now I'm sharing it with everybody, all in all. It's pretty nice. Now, some people argue that the social sciences are not sciences, but they are. They're just kind of softer. It takes a little bit more proof. It's a little harder to do because people are complicated, very complicated, even more so than, the universe, animals, atoms, that sort of stuff. But a proper social scientist can be a good thing. They can actually find things. You do have to watch out, though, for pseudoscience, because those things are rife with pseudoscience. The world is. Pseudoscience looks like science, but it's not. So it is advertised often as science, but you need to be careful because it's not. This is dangerous. They typically do not have proper standards, oversight, or quality control, meaning they can pretty much say whatever they want to say, call it official, and that can hurt people. Some examples are astrology, the hollow earth theory, mesmerism, phrenology, cryptozoology, feng shui, and many, many, many more. There is tons of them. In fact, I have a link there to a Wikipedia page that lists several hundred of them. Several things that are not really science, but try to pretend they are, like aromatherapy and Reiki. Those are also pseudosciences. Pseudosciences are overly vague. It holds testimony over fact, like what people say versus what is actually reproducible and that you could then do yourself. They're often misleading. Now, they often use the burden of denial. So you heard the burden of proof. If I say something, I have to prove it. That is science. The burden of denial. If I say something, you have to prove it's wrong. Do you get that? And you get the difference in that. I'm going to demonstrate that right now. without any evidence, I'm going to let you all know a secret. I'm really a dragon. Yep, I am really a 50-foot long, fire breathing lizard that terrorizes small villages during the summer. I can't help myself. It's part of my nature. I've got claws that can shred steel, and I can eat pretty much anything. Because you know dragons, many of them, can take human form. So I'm a dragon. How many of you believe that that's true? Thank you. I mean, I'm not giving you any evidence, but I'm glad that you think that that's okay. I mean, that's not a good way to think about it, really. I mean, I really should come up with proof. If I'm going to make this really weird claim that I'm a dragon, don't you think I should have something to back that up? I mean, even family photos of me like rampaging about a village, you know, I mean, no, none of that. But see, that's the thing. I don't have to provide it because I'm not acting as a scientist with it. I am putting the burden of denial on you. I am stating something as if it is fact, and I am not backing it up. I'm making you disprove me. And by the way, if you're like, Mr. D, I want a blood sample then, I'm going to say no because I don't have to be open to testing. I can deny your chance to find out if it's true, even though I'm making you claim and prove that my statement is BS. Do you see the subtle difference between burden of denial and burden of proof? That makes all the difference. Now, you will find in many ways, especially in our modern world, this crap happens a lot. Oh yeah, it does, a lot. And even people in educated and as smart as I can fall for it. I'll get that to just a second. Because let's talk about pseudo-spread, the spread of pseudosciences. So, several sources are common cognitive errors from everyday experiences among people. Meaning, normal people see something, talk about it, jump to the wrong conclusion, but they say it to other people and they're like, oh yeah, I saw that too. So they believe the wrong conclusion. Okay, that's very common. An incorrect sensational media coverage. Yep, something gets popularized, it shows up on social media, it's some sort of quiz that you take or whatnot. This happens all the time. Right? Sociocultural issues, also known as folklore, that are untested. Oh, if I knock on wood, that'll ward off evil. Will it? Well, I haven't had a goblin attack me yet, and that's because I knock on wood. But do you see how that doesn't necessarily matter? Like, there's not actually a connection there. But I'm stating that there is. I am misusing some folklore. Knocking on wood doesn't in any provable way actually ward off evil. Now, as a scientist, I have to keep open to the idea that maybe it does. But the burden of proof would then fall on whoever's making that statement. You see how that is? They would have to prove that it works. And many times pseudoscience cannot. Poor or incorrect science education. Yep, there it is. That's one of the reasons pseudoscience is spread. Your education's bad. Whether it's from something the teacher says that's incorrect, or maybe you're just not paying attention, or maybe you decide that everything that I say is BS because I'm not posting it on Facebook. Sure, fine. I mean, it's wrong, but there it is. Now, you might be like, Mr. D, you just told us all this, but why should we believe you? Well, first off, here you go. All of this was reported by Singer and Benassi in their study in 1981, and it was supported by the Even Done study in 1990. You can now look up those studies, and you can read all the stuff I just told you that someone else had reported as well. This is part of what separates science from pseudoscience. Now, pseudoscience will give you testimonials. They'll say, oh, look, Robert down the street, he says that, you knock on wood, the goblins go away. Robert, listen to Robert. See, I have a source now. That's the thing. If you go talk to Robert, whatever, Robert may not be a good source. Robert may not know what he's talking about. You can check these now. I have given you all the tools you need to check what I just said.